All right, guys, so this is the video that goes with the notes page that's entitled Quadrilaterals in the Coordinate Plane Practice Problems. Okay, so there's just 3 examples on this, but they are a little kind of time consuming and have a lot in them, so it's going to have their own video. So this video is dedicated to that particular page. So I'm going to pause this, and what I want you to do is I want you to go through and just plot the points on the graph. That way we don't have to stop to do that. So go ahead and just plot the points. Make sure you label them A, B, C, D, or whatever, and then we'll start going over example 1. All right, so in example 1, it says, decide whether parallelogram ABCD with these vertices, and you should already have them plotted, is a rectangle, a rhombus, or a square. Give all names that apply. So remember, if it's a square, that means it's a rhombus as well and a rectangle as well. Okay, so make sure we give all names that apply. All right, so the easiest thing to do here is to find these slopes, because we can just count. There's not a whole lot of math involved in finding slopes. So I'm going to find the slopes of AB. I'm going to find the slopes of BC, of DC, and of AD. Okay, I'm going to find all these slopes. And remember, if these slopes are the same, so same slopes, that means they're parallel. If they're opposite reciprocal slopes, that means they're perpendicular. Okay, so AB goes up 1, 2, right 1, 2, 3, 4, 5, 6, 7, 8. So the slope of AB is 2 over 8, which reduces to 1/4. Okay, so BC, I'm going up 1, 2, 3, 4, 5, 6, 7, 8, right 2, so 8 over 2, which gives me a slope of 4 over 1. Okay, DC, I'm going up 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8. So 2 over 8, which reduces to 1 over 4. And then the slope of AD, I'm going up 1, 2, 3, 4, 5, 6, 7, 8, right 2, which is the slope of 4 over 1. Okay, so I notice that this one and this one are the same, meaning that BC is parallel to AD. Okay, well, it tells it's a parallelogram, so we already should know that. And then this one's 1/4, 1/4, which means these sides are parallel. Okay, now if I look at this, I'm going to ask myself, are these opposite reciprocals? Okay, if they are, then that's a 90-degree angle. If they're not, then they're not a 90-degree angle. And these are not. They're reciprocals, but they're not opposites. If one of them was a negative and one of them was a positive, then they would be opposite reciprocals, and we would talk about 90-degree angles. But notice all these are positive slopes, so none are opposite reciprocals. So I can say that I have no 90-degree angles, therefore it is not a rectangle or a square. All right, so we know it's not a rectangle or square. So now we want to see if maybe it's a rhombus. Okay. Now be careful here, because most people, what they want to do is they say, oh, well, rhombus has all 4 congruent sides. So let's do the distance formula 4 times and see if they're all the same. And while that's not incorrect and you'd find what you needed to find, that's very time consuming. And as you guys know, the distance formula, it's very easy to make a mistake. Okay, it's very tedious. So I'm going to use the fact that if this is a rhombus, then the diagonals will be perpendicular. Okay, so I'm going to check the slopes of the diagonals to see if they are opposite reciprocals. Okay, so I want to find the slope of DB and then also the slope of AC. So the slope of AC, this has a negative slope. Okay, I can tell because it's going down. So it's going down 1, 2, 3, 4, 5, 6. and write 1, 2, 3, 4, 5, 6. So negative 6 over 6, which is negative 1 over 1. Okay, now I want to find the slope of BD. Okay, so BD, I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So positive 10 over 10, which is positive 1 over 1. These are opposite reciprocal slopes. And because they are opposite reciprocal slopes, I know that this has to be perpendicular. These are perpendicular to each other. And if you remember, if we go back to a rhombus, if the diagonals are perpendicular, then it's a rhombus. Okay, so I can say that this is a rhombus, but a rhombus only. All right, let's look at example 2. Now, example 2 is a lot like example 1. So it says, decide whether parallelogram PQRS with these vertices, and you should already have them plotted, is a rectangle, a rhombus, or a square. Give all names that apply. All right, so I want you to use example 1 that we did as a reference, and I want you to work through this and decide what shape this is, and then we will go over it. All right, guys, so hopefully you went through and you did these. The first thing I did is I found the slopes of all the sides of this. And so I either got 2/5 or negative 5/2, okay? And if you notice, these are opposite reciprocals. And because they're opposite reciprocals, that means all of these angles here are right angles, okay? Opposite reciprocals mean things are perpendicular. If they're perpendicular, they have right angles. So from that, I can tell you that it's a parallelogram with all right angles. That is a rectangle. Okay, then I went a step further. I drew in these diagonals, and then I counted boxes, and I found the slopes of them, and I found the slopes were 7/3 and negative 3/7. Once again, those are opposite reciprocals, so they are parallel, meaning that these all are right angles, okay? Which means that this is a rhombus. Okay, so it's a rectangle and a rhombus. And if it's a rectangle and a rhombus, it means it has 4 90-degree angles and 4 congruent sides, which by definition is also a square. So all 3 of these is true about this figure. All right, let's look at example 3 now. This is the last of them. Now, example 3 wants us to see if QRST, or it wants us to show that QRST is a trapezoid, then decide if it is isosceles. Okay, well, first of all, if it's a trapezoid, that means that one pair of opposite sides are parallel. Okay, one pair of opposite sides are parallel. Now, if I look at this, I know that this side here and this side here can't be parallel because this one's going straight up and down and this one's moving left. Okay, so those can't be parallel. So my 2 parallel sides would have to be this one and this one. Okay, so I need to show that RS is parallel to OT. Okay, so we need to stop and think, how do we know if 2 lines are parallel? Okay, if 2 lines are parallel, that means they have the same slope. Okay, so I'm going to find the slope of RS, and I'm going to find the slope of OT, and if they're the same, then those are parallel. So RS, I'm just going to count up 1 over 1, 2. Oops, up 1 over 2. Okay, and then OT is up 1, 2 over 1, 2, 3, 4. So 2/4, which simplifies to 1/2. Okay, so 1/2 and 1/2. So these are the same, or they have the same slope anyways. And so because they have the same slope, I can say that RS is parallel to OT. So yes, it is a trapezoid. All right, now it wants us to say whether or not this is an isosceles trapezoid, okay? So to find out if it's isosceles, I'm going to look at the 2 legs, Okay, there's only one way to know for sure if these two legs are the same, and that's to do the distance formula. Well, I can tell you RO, it's straight up and down, so I can just count boxes. 1, 2, 3. This has a unit measure of 3. Okay, now I have to use the distance formula for ST. So square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so S and T, here's S, here's T. And so I'm going to use 2, 4 and 4, 2. All right, so square root of 2 minus 4, don't forget the squared, plus 4 minus 2 squared. So this is just a negative 2 squared plus 2 squared, which is a square root of 4 plus 4, which is a square root of 8. Square root of 8, guys, is not equal to 3. The square root of 9 equals to 3. Square root of 8 is less than 3. So no, they are not the similar. So this is not an isosceles trapezoid.